prepare them. This course is designed for anyone who wants to increase their computer skills and knowledge, even if you're just starting out. Employers search for IT professionals with valid real-world skills. So we'll teach you the knowledge and skills they look for so that you can begin your career in computers. Before we go any further, it's important that you understand the prerequisites for this course. We're assuming that you already know a few basic things about computers. First, we'll assume that you know how to turn a computer on. You should know how to interact with the computer using a mouse and a keyboard. And we expect that you know how to run basic applications on a computer system. For example, you should be able to turn on a PC, open Microsoft Word, open a particular document, make changes to the document, and save the changes. We're also going to assume that you understand how to use a web browser and an email client to access information on the internet. Those are all prerequisites for this course. The purpose of this course is to provide you with the equivalent knowledge of an entry-level computer technician with about 12 months of on-the-job experience. To do that, we're going to go over these topics. First, we'll discuss how computers and operating systems work. We'll review a computer technician's job role, how they spend their time, and how they should act on the job. We'll discuss the components that comprise a computer system. We'll take a look at storage, motherboards, processors, memory, and so on. We'll also discuss how to manage computer storage, how to make sure data is stored safely and securely, and how to make it accessible. We'll also discuss some computer networking basics. We won't discuss them in much depth, though. If you want to learn more about computer networking, you should take the Network Pro course and get your Network Pro certification. We'll just give you a brief introduction. We'll also discuss how to manage printing and mobile devices, a very important aspect of managing computer systems, and we'll introduce you to virtualization and cloud computing. Then we'll move away from hardware and discuss the software that runs on a computer system. We'll discuss how to manage desktop operating systems. We'll talk about how to implement a computer system from a hardware and software perspective, and how to manage files in the file system. Then we'll look at how to secure desktop systems. Specifically, we'll discuss how to make sure that the right people are able to access the right information. And throughout the course, you'll learn how to troubleshoot common computer problems. LabSim provides several features designed to help you learn and retain basic computing concepts. Each section provides you with videos and demonstrations that teach you how to perform necessary tasks. Fact sheets help reinforce the concepts taught in the videos, and interactive hands-on labs let you practice the skills you've learned. Within each section, you'll find practice questions to test your knowledge. At the end of the course, you'll find both a PC Pro certification practice exam and A+ practice exams. These exams will help you prepare for certification. Consider using the exams as a pre-test at the beginning of the course to determine how much you already know about computing. Then, as a post-test, retake the exams at the end of the course to see how much you've learned. You can also test your knowledge by taking the domain test. The domain test divide test questions up according to the domain objectives in the certification exams. It's another way to practice and reinforce basic computing concepts. Now let's talk about your certification, because that's really the goal of this course, to provide you with the information you need to become industry certified as a PC technician. Certification is important if you plan to have a career in the IT industry. Certification provides two benefits. First, it gives employers critical information they need to make hiring decisions. Second, it gives you an edge in the job application process because employers look for certification. This course meets the specifications for two different industry certification programs, the TestOut PC Pro certification and the CompTIA A+ certification. The TestOut PC Pro certification measures how much you know and what you can do. The PC Pro cert validates that you have the equivalent knowledge of a computer technician with about 1 year of work experience. It demonstrates that you know the basics of how computers work, how to install, configure, and troubleshoot computer hardware, and how to install, configure, and troubleshoot networking connections. In addition to that, PC Pro takes things a step further by emphasizing real-world job skills. In order to get your PC Pro certification, you won't answer a whole bunch of multiple choice questions. You'll perform real-world tasks. The A+ certification is an international certification program created by the Computing Technology Industry Association, or CompTIA. The CompTIA A+ certification covers generic PC concepts. It's not focused on one particular vendor's hardware or software. The A+ certification program tests how much you know. It doesn't focus on what you can do. The online exam is composed of multiple choice questions. The A+ certification is composed of 2 different exams. The first exam is 220-1001, which tests your knowledge of mobile devices, networking, computer hardware, virtualization and cloud computing, and hardware and network troubleshooting. The 220-1002 exam tests your knowledge of operating systems, security, software troubleshooting, and operational procedures. So, as you can see, the A+ certification works hand in hand with the PC Pro certification to verify that you know what a computer technician should know and can do what a computer technician needs to do in their job. With this introduction in mind, it's time for you to start learning about how computers work. In this video, we introduced you to the PC Pro course, the course audience and prerequisites, the topics covered in this course, and the certification that this course will help you achieve.
All right. So there's quite a bit in this PC Pro course, and it covers a lot. And obviously, these certifications are very, very important. But the hands-on training that you receive within the simulation labs are they're very useful. So just keep that in mind. So let me just check, Jackie. I generated that temp password again. Did you receive an email? So I want to make sure you can get in before I get started on the labs with everyone.
I got the email, so I'm testing it right now.
Okay, thank you. All right, so while I'm waiting for Jackie to verify that she can get in, according to our lesson plan, we are going to start basically setting up your PC. The first lab that we're going to do today is just the 113, which is essentially, and hopefully you're all very comfortable with the simulator and the workbench environment. So we're just going to walk through an exploration of the workbench and the simulator. I know this is pretty much a repeat, but I do need you all to complete. There's 4 labs for today and 6 labs for Wednesday. And these are required for completion. And then Wednesday, you also will have 3 homework labs. So, and I do need to check that and submit a weekly report. So make sure you are either walking through the labs while I'm going through them, or these first couple, you probably get them done pretty quickly, but these are required as far as the course content, and this is how you're graded. So in this lab, we're basically going to check out the simulator again. We've done a lot of this already. We're just basically adding components to our workspace and connecting cables. So, and of course, I still need to practice, so I'm not going to dismiss the labs. So what we want to accomplish, we want to add a monitor. We want to connect a monitor to the desktop, which with an HDMI cable. An HDMI cable is your video and audio cable. It's kind of the newer generation of cables for video display. You probably have HDMI cables on your smart TV or ports on your smart TV. As a matter of fact, you can use your smart TV as a monitor. I often do that. And we want to connect the power cord, and then we just want to turn on the monitor. All right, so the first thing we want to do is we want to grab a monitor from from our shelf and put it in our work environment. And remember, basically, you find a highlighted area and add it. Then use the back button to turn them around. All right. Now we want to choose our HDMI cable, which is this cable here. So you have two cables in there. One's the HDMI, one's the power cable. Oops. I need to situate my video so it's not in the way. All right. All right, so we're just going to connect one end of the cable to our monitor, and it's the HDMI port. And just to explain the ports, if you don't know them, there's a digital, a DVI port, the old VGA analog port, and then your HDMI is a smaller one. So you go ahead and connect that to your monitor and connect the other end to your desktop. And let's see, where's that? It's not that one. So the ports on either end of the HDMI are the same. All right, so now we want to grab our power cord, select our female end into the back of the monitor, and then our regular power adapter in into the power strip. Okay, so let's go to the front. Turn them around. Turn on the monitor. The little button is right here on the right bottom corner. You turn that on, and generally if you don't have a signal from your PC, so we can turn on our PC and it'll go through its boot up process. And now we've added our monitor, our nice fast monitor to our workstation. Yes, that's very basic, so I'm pretty sure everyone has a grasp on that. Any questions about this lab? Yep, stop yawning. I know you're yawning. No yawning. We'll get through. We'll get to the hard stuff. Just wait. Just you wait. All right. Okay, so let's move on to our next video. We try to keep you engaged. Yeah, I'm going to use that. And that's going to be just some computing basics. And this goes into hardware. Some of the things that you need to kind of catalog. No need to memorize any of this. Just keep in mind what we're trying to set as a foundation for you to learn. So here we go.
As a PC technician, it's very important that you understand the basic components that make up a computer. Computers are made up of constituent parts that work together to create a functional computer. These parts can be divided into two main categories: hardware and software. Hardware refers to the physical components that are installed inside or connected to a computer system. By itself, hardware can't do much. It needs instructions to tell it what to do. These instructions come from the software. Software refers to instructions or data that are stored electronically, either on a hard drive or on a special chip. Hardware without software is kind of like a car without a driver. A car has the potential to drive, but it needs a driver in order to see the potential. Without a driver, the car can't do anything. The same is true with hardware. Hardware has a lot of potential, but it needs software to instruct it to use that potential. The main thing to remember is that hardware is the potential. Software is the instructions. In this lesson, we're going to take a look at the different types of hardware devices that compose a computer system. The first type of hardware device we'll look at is input devices. An input device is any piece of hardware that takes information from outside the computer and transfers it inside where the computer hardware can use it. The most common input device is a keyboard. A keyboard takes user inputs and sends them as electrical signals to the internal computer hardware where they are processed. When a key on a keyboard is pressed, an internal chip called a scanning chip identifies which key was pressed and then sends the appropriate code to the computer. The code could generate a letter in a Word document, a number in a spreadsheet, or a command for the computer. Another very common input device is a mouse. A mouse also uses inputs and sends them as electrical signals to the computer, but it does so a bit differently. A mouse tracks movements as XY coordinates. These coordinates are sent to the computer, which causes the mouse pointer to move in the same manner. The way a mouse tracks movement depends on the type of mouse being used. The most common type is an optical mouse. An optical mouse uses a light source and a sensor to track movement. A less common type is a mechanical mouse. A mechanical mouse uses a trackball, which rolls when the mouse is moved, along with sensors to identify which direction the ball rolls. Chances are you are very familiar with using these two input devices. Another input device you are probably familiar with is a touchscreen. If you've used a smartphone, tablet, or a computer kiosk, you've used a touchscreen. Instead of key presses or movement tracking, a touchscreen takes user input from screen taps. There are two main touchscreen technologies, resistive and capacitive. Resistive touchscreens use two flexible layers that are separated by a gap. Inside the gap is an electrical current. When the screen is tapped, the outer layer depresses and contacts the inner layer, creating an electrical signal that identifies XY coordinates. The coordinates are then sent to the computer. Capacitive touchscreens use a screen that is coated with a conductive material. An electrical current is then run through the material. When something conductive touches the screen, such as a finger, small sensors identify the touch and generate XY coordinates. Capacitive touchscreens are used on smartphones, tablets, and some laptops. But because they require a conductive touch, a non-conductive object, such as gloves or plastic, can't be used to tap the screen. Resistive touchscreens are typically used for airport or library kiosks. Because they require only pressure, any rigid object can be used to tap the screen. Now, signals generated by input devices need to be analyzed. This is done by using a processing device. A processing device is any hardware component that can analyze and interpret input information. The most common processing device is the Central Processing Unit, or CPU. The CPU is like the brains of the computer. It processes data according to a set of instructions or software. For example, when the A key on the keyboard is pressed, the keystroke information is sent to the CPU where it's processed based on the software that is currently running. If we were running word processing software, the letter A would appear at the cursor location in the open document. But if we were running a game, it might make the character move to the left. Another processing device is random access memory, or RAM. RAM is used to store processed information so it can be quickly accessed at a later time. For example, if a CPU were to process data from a spreadsheet software, but still needed to access that data at a later time, the data could be stored in RAM for quick access. RAM is also used to store running software. RAM can also be considered a hardware component called a storage device. A storage device is any hardware component that stores data, either temporarily or permanently. When data is stored temporarily, short-term storage such as RAM is used. It's important to know that RAM is considered volatile memory. It's not persistent. This means that when the power source is lost, for example, the computer is turned off, all the data that was stored in RAM is lost. It's gone forever. Now, you might be wondering why we would use a storage device that is erased every time it loses power. Well, the reason we use RAM is because it's extremely fast. Information can be accessed from RAM faster than any other type of storage hardware. But sometimes we need to store information permanently. This is done using long-term storage. Remember, short-term storage is lost every time the computer is shut down. Long-term storage, however, is considered non-volatile memory. It's persistent. This means that even when the computer is turned off, the data stored on the hardware will still be there when we turn the computer back on. There are a variety of long-term storage media. The most common one is a hard disk drive. Hard disk drives store information on rotating disks called platters. Another common medium is a solid-state drive, or SSD. SSDs use memory chips that are a lot like RAM. However, the information stored on these chips is persistent. Hard disk drives and SSDs can store a lot of data and access it relatively fast, but not nearly as fast as RAM. This is why we use both hard drives and RAM to store data. We also have optical storage media, such as CDs, DVDs, and Blu-ray discs. Now, optical storage media can either be read-only or writable. If a disk is read-only, the information it contains is fixed and can't be modified or erased. It can only be viewed. An example of a read-only disk is a software CD-ROM or DVD-ROM. The ROM at the end actually stands for read-only memory. Writable disks, on the other hand, can be modified. Disks that are writable have an R or an RW at the end. For example, CDR, DVD-RW, BDR. The R stands for recordable. Unlike their ROM counterparts, these types of disks can have information saved to them. There are two more long-term storage devices we need to talk about. The first is a flash drive. Flash drives are small, portable devices that use memory chips to store information. These memory chips are very similar to RAM chips. However, the information is persistent. The second is a secure digital or SD card. You might be familiar with these. SD cards are used in smartphones, tablets, and digital cameras to store information. They use non-volatile memory. Now, all the information that is being input, processed, and stored on a computer is useless unless there is a way to access and view it. This is done by using an output device. An output device is any device that receives data from a computer and outputs it in a physical medium. The most common output device is a monitor. Monitors are used to visually depict the data that is processed by the CPU. Whether it's numbers being calculated in a spreadsheet or aliens running around a video game, a monitor displays a visual representation of the information being processed. Another very common output device is a printer. Printers take information that is processed by the CPU and print it on a piece of paper. Both monitors and printers output visual information, but there are more than just visual output devices. For example, another output device is a sound card. Sound cards take digital information and output it as audible signals. Almost all computers have some sort of audio output device. Now, all the devices we've talked about so far communicate information within a single computer. However, there are other hardware components that allow information to be communicated between multiple computers. These are known as networking devices. Networking devices are used to create networks. A network is a group of two or more computers that are connected together. To create a network, a special interface is installed in a computer. A connecting medium is then used to connect the computers together. This connecting medium can be a physical wire or even radio signals. With this connection established, these two computers can take information being processed by the CPU and send it to each other. This makes networking hardware both input and output devices. When one computer is outputting information, the other is inputting information, and vice versa. Now, there's one more aspect of computer hardware that we need to talk about called modular design. Modular design is a design approach that standardizes hardware interfaces in order to create modular hardware components. This means that a monitor that works on one computer can be connected to a different computer and still work. The monitor is modular. While this may seem commonplace today, it wasn't always the case. In the early days of computers, hardware components were actually proprietary. This meant that if a piece of hardware in your computer died, you couldn't just go to the store and buy a replacement. You actually had to ship the component, sometimes the entire computer, back to the manufacturer in order to get it fixed or replaced. Luckily, this isn't the case anymore. Because computer hardware is modular and standardized, you aren't limited to specific manufacturer or brands when buying or replacing hardware components. For example, if you want to install another hard disk drive in your computer, you don't have to buy it from the same company that built your computer. Any brand of hard disk drive will work. So, those are the basic hardware components of the computer system. Remember, there are two main computer component categories: hardware and software. Hardware is the potential, software is the instructions. In this lesson, we looked at the various hardware components that comprise a computer based on the 5 main functions they perform: input, processing, storage, output, and networking.
All right, so I know that was a lot of information, and so there'll be a pop quiz in about 10 minutes on every aspect of hardware and software. Are you all ready?
We're ready.
Okay, who said
Yeah.
that? Is that, okay, well, the quiz is upcoming, so prepare yourself. Now, that video went over some very, very useful components as far as hardware and software, and basically what you will all get to learn about basic computing So, yeah, and as I said before, you don't have to memorize any of that, but it's a lot of information, and it actually is still growing from the basics. Any questions about any parts of the video? No, you're all very quiet tonight. I know it's Monday and all. I do want to point out that if you view the lesson plan, it does have on there a list of study guides. And basically these guides will help you to capture some of the information that are portrayed in the video, some of the labs. For example, this 122 here, computing facts, if you open that up, basically it will highlight everything that was, essentially discussed or conveyed to you in the video, input devices, output devices, etc. And you need to, these are very useful because these particular categories are usually questions on the certification exams. So make sure you open those up, take a look, reference them when you have to, and just use those as, because that's why they're there. They're basically study guides, and they have, this one has computing facts, and you can essentially pull out some of the aspects of what we breeze through, because in many instances we'll talk about something and you may need some detailed referencing. So that's what those are. All right. On to our next lab. 115. I know you're all excited. So we're going to connect some internal components. Woohoo. How many of you actually have torn open a desktop and started, pulling things apart? And oh, wait a minute, there's a monster or a cat, or is that Batman? Okay, who's that mysterious character?
It's Batman.
Yeah, he was very scary. I was very nervous. Oh, it's a Lego Batman. It's a very big one. All right. I was very confused. I thought I had to let him into the classroom. So, all right, internal components. That's our next lab, right? Or am I skipping ahead? I'm skipping ahead. Yeah, connect internal components. All right, so in this lab, excuse me, your IT administrator for a small corporate network you're working on a computer in your office. In this lab, we're going to complete the following tasks. We're going to install memory from the shelf into an open memory slot. We're going to install a network card, commonly known as a NIC, and then open PCI. And a PCI is a type of slot that's still used, and it's PCIe now. And you'll learn all about what that means. We're going to take a SATA or SATA cable to the data connection on the CD drive, and basically you're connecting an external internal CD drive in your desktop. We're going to also connect power. We're going to connect a 20 plus 4-pin motherboard power connector to the motherboard. We're going to connect a power supply, a 15-pin SATA power connector to the power connection on a CD drive on the left of the drive. We're going to connect the CD drive SATA cable to the SATA connection on the motherboard. And after all that, we're going to see if we can actually start the computer. So you've all done this before, right? You've opened up your desktop and pulled all those things out, put them back together, and then your computer won't start. All right, so let's follow the directions. So the first thing we want to do is from the shelf install a memory module to an open memory slot. And actually we have our motherboard here. You all know what that is, right? That's our motherboard. If you open up your PC, take the side panels off, You look at this thing with the big fan and all that. So where are the memory slots? Who knows where the memory slots are? You're like, I have no idea. All right. Let's take a look at those memory modules.
It was just the right of the fan.
Just
Right
the
of the
right of the
fan.
fan. All right. So we can take a memory module here, and I'm assuming you're saying these are memory slots.
That's my story.
That's your story. So we're going to take one of these memory cards and plug them right into the memory slot. And if you've seen a motherboard before, essentially most of them you have two actions. You don't just slide it in. You have to tilt it a certain way and then lock it into place. Of course, we're not going to simulate that, at least from what I can tell. I'm assuming that memory card is now situated in that memory slot. All right, are we all good with that? And we just added 8 gigs of memory to our motherboard. Woohoo. Now,
Hey, Dwight, is that the same thing? Are you adding RAM to it, basically?
that's correct.
Okay. All right.
Yep.
And would it essentially be, I mean, obviously it wouldn't be the same, but would it be the same concept in a laptop almost?
It's the same concept. The memory cards are very, very different, but it is the same concept. Yes.
Okay. Thank you.
All right, so second, we're gonna go to our shelf and install a network card. Now, who can tell me where the network card is going to go? Where do we find that?
A little lower, a little lower. Oh, come on, to your left. Up, down, down. Oh, down, down, down. To the left, to the left, to the right, right. Right there, there you go.
This little place? All right, well, let's take a look at the network adapter. Oh, it has, and this is true of network adapters. It's sailor proof, as we say. You can only place it in one of the slots in your motherboard. None of the other slots will, it will fit. And it's a PCI, which means that it will have a little place here where you slide it into essentially a placement holder and then plug it into the slots on the motherboard. So you see this little extension here. Essentially that goes into these little side holders here. So, and this is hard to simulate, but we are going to try. Oops, stop that. So we're going to put it right there, right? And as you see the simulation, essentially it slides into this area on your PC and goes right into that, where it fits these slots, and all that goes into a certain part of the holder for the network card. All right, good. Next, we're going to pull a SATA cable, and it's a cable that looks pretty complex. Let's take a look at it. And we're going to plug that. Where are we going to put that? How does that work? All of you smart guys, what do we do with that? Doesn't look like it goes on the motherboard. Where does it go? No takers? Where does that go?
Drive bay. Drive bay.
Where the heck is the drive bay?
The one, the box on the top of the, is that one.
And we have to actually, this is too easy. They give us and essentially it shows you essentially where you're placing that. So right in the back, internally, you'll see where your drive would slide in, essentially either a CD or a hard drive. All right, so now what? What do we do with this cable?
Connect one end to the number 2 for the power supply and the SATA cable.
And well, this looks like a power supply there. No.
No, enlarge the
This,
drive bay on the computer.
right?
No, that one, that image.
Uh-huh.
You'll be on the right side.
Yeah, on the right side, that's the SATA cable. Make it larger.
Yeah, my touchpad is very finicky.
Oh,
I'll get it. This is a Mac. All right.
You can use the control right above workspace, blue, and there's the other option
Right.
to grab to the right.
All right. Okay, so
smaller one.
where's that cable going then?
On the smaller one of the two.
On the smaller one of the two. Oh, you guys are really smart. So I'm going to put that right here, right?
Yes, and the other one on the motherboard. Oh, and then this one, click the power supply. To get the other one. And then,
Well, let's finish this one.
okay, on the motherboard.
So now we have it plugged in.
Yep, to the bottom left, right.
Where the blue one is.
Uh-huh.
Yeah, those slots, the.
Those are SATA slots there.
Yeah.
Yeah, you guys done this before. All right. Now what? Here's our power supply.
Then the power supply, you click on the power supply.
So from the power supply, plug the 20+4 pin motherboard power connector to the motherboard.
Yeah. Click, oh, the power supply, click on the power supply. Beneath the motherboard.
Yeah, we're getting there. All right. So we want the 24
Pin.
That's a lot of cables. And
Yeah.
where are we going to connect that?
On the far right side of the fan.
Uh-huh. Right there. It looks pretty complex. All right. All right. Okay, so now we have power, actually power from the power supply to the motherboard. We have our memory, we have our network card, we have our drive cable. All right, so now we want to connect
The 15-pin SATA connector on the drive bay.
so we're taking our 15 pin and where are we connecting that?
On the drive bay.
So we're going to connect that one into the, where does that go? Now, is that the 15 pin or is that another cable?
15 pin, sir.
Pardon?
15 pin.
Yep, and where's that plugging into?
Going to the drive base on the left side of the where the one you connected on the SATA. Left side. On that left side, yeah. Just right after the, if you're gonna enlarge it, you're gonna see it.
So is it going here?
In the middle, no, in the, just
There.
right, yeah. Right at the side of that red one.
And we want, this says we want to plug a 15 pin SATA power cable.
Yeah, the unconnected one. Oh, click on the power supply, not that one.
Yep, we don't want that one here. So
There you go.
there it
Unconnected.
is. So we're going to plug that one in there. All right, now we have power with the drive base. So basically, we just added power to our DVD drive or CD drive in this case. All right.
Dwight, the SATA cables or the SATA cables pretty much supply power to what the drive, or?
Yeah, it's usually power and data, depending on how it's set up. Usually the SATA, you have a separate one right from the power supply to your drive and right from the power supply to your motherboard. Yes.
Okay. So those are for the two SATA cables that were, I guess, put in on this particular example is for two different drives, or no?
No. Say
Just
that
one
again.
drive.
Okay.
No, it's a single drive.
Okay.
Right. And you see that one came from the motherboard, one came from the power supply.
I see. Okay.
If you go back to the motherboard, the red cable, and then this one came from the power supply right to which is actually down here.
So the last one that you just connected was to give it power, though, and the other one was to connect it to the
Yeah.
motherboard.
That is correct.
Oh, okay. I got it.
That's a bus, and we'll learn about data transmissions and all that.
Okay.
Stuff. All right. So I think we have everything connected. We're hoping to have our fingers crossed. So
Verify it start.
we're going to see if our computer starts. So we click our start button. And if we didn't connect everything correctly, we'll get all types of errors. And they would be boot errors, and it seems like, yep, we reach our desktop, so we're fine. We don't have any warnings, so good job.
Yeah.
We connected all our cables. Any questions about that lab? That one's quite involved. And I hope that you're all doing this lab along with me. Remember,
Yes, sir.
you are required to complete these labs. All right, let's see.
Yep.
Yay, success. Good job. All right. Do we need to take a quick break or should we continue? Yeah, I think let's just take like a 10-minute break, stretch our arms,
Okay.
something to drink, and then we'll finish up the labs for this evening and get ready for Adam. All right.
All right.
10 minutes.
Right.
We'll start up again at 6:40. So it's a little.
Okay.
Thank you all.
Thank you.
Oh.
I'm just reading the chat.
By the way, sir, what time do we start? At 5:30, right?
Who's speaking?
Oh, James, this is James. I'm sorry.
Oh, James, yeah, you joined
Yeah.
us. Yeah, we generally start at 5:30, a little after.
Okay.
I'll try to be on time mostly, but I want to make sure everyone's in.
No, I came late. That's why. Yeah, when I came in, you're like everybody was already here.
Yeah,
Yeah.
your classmates are very punctual, so
Yeah.
I usually start on time. So
Yeah.
let me stop sharing my screen for a bit. All right. All right, we'll start again at 6:40.
Yes, sir. 40. See you then.
All right. Some of the aspects so that you can return to them even in real life and talk about or even perform some of these tasks without even thinking too much. Okay, so we're going to move ahead on our lesson plan. And remember, if you have any questions, just stop me. Let's see, what's our next video? Actually, we're going to go through another lab first. Let me share my screen. All right, so our next lab, is that right? 127. We're going to set up a computer. Yay, these are always such fun. So we go from internal to external. Yeah. And yeah, don't be confused by these the flows of the flow of the lessons. They're designed to confuse you because confusion is a better part of learning. But now we're going to essentially, we just got the big box full of computer parts. We're going to set them up on our desk. So your IT admin for a small corp, you just received a new computer and you're tasked to set it up in your office. You're going to plug the power strip in the wall, plug the computer in the power strip, connect the keyboard, mouse, speakers, add the monitor, printer, plug in the monitor, printer, and connect the computer to the network port and the wall plate. So use these tips to help you complete this lab. And basically it says make sure you view the details of each of the cables, ensure that you're attempting to put the right cable in the right port. Although it's not really that hard anymore. There's no cables that are similar enough that you're cramming them into, especially external cables. So, but you know, yeah, you can make mistakes, but you'll see that this is pretty straightforward as far as the lab goes. Right, so this is lab 1.2.7. And so the first thing we want to do is plug the power strip into the wall. Woo. So we want to pull a power strip from our shelf. And let's put it next to our software. And we want to plug it into the wall. Okay, and we're going to turn it on. I think it is on. All right, so we want to plug the computer into the power strip. So we need a power cable, good old standard 3-prong. Yeah, you'll see that these types of cables can be plugged into many, many, many different devices. As a matter of fact, I have a whole box full of these from my old tech days. So we're going to plug it into the back of our desktop if it works. And into the power strip. Okay. All right, so far so good. We want to connect a keyboard, a mouse, and a speaker to our desktop. So let's go back to our shelf. And what type of devices are those? Quick. What's a keyboard? What's a mouse?
Input.
Thank you. And speakers? Are speakers input or output?
Output.
All right. And throw our keyboard there. And oops. I'm ending my Zoom session. So these type of cables are USB type A, very, very standard. And we're just going to plug this into one of our open ports in the back of our desktop. And we're going to add our mouse. And also plug it into one of our ports in the back of our desktop. Okay, now we have speakers. So I'm going to add those. If I don't break the system. I'm going to put them right there. And these usually come with a 3.5 millimeter TRS connector. And usually you can go by the color code and make sure you plug it into the green port. And that's usually the output port. You may have stereo speakers, et cetera, et cetera. And basically, if you follow the guidelines, it's pretty simple to ensure that you have sound. And that's usually the case because you see these ports that are very similar and this is where you're checking, then I would recommend starting your computer and then checking to see if you have sound and actually test the different ports. All right, so far so good. Okay, so now we need a monitor and a printer. So we had our monitor. And we have a printer. I'm gonna put the printer way over here. It's a USB printer. Ooh. Wow. This is a wacky structure here. Odd place to put a printer, but put it there. All right. So let's go back to our monitor. And we want to make sure we have the right cable. Now we can you probably have all of these cables. Which cable would you recommend for your monitor? HDMI, DVI, or VGA? What do you think? You probably have access to all of them. We have DVI here.
DVI.
You know DVI. All right. So we select our DVI. One end goes into DVI. Remember, the DVI is different than the VGA as far as the pin count. And then we want to make sure we select the right port on the back of our desktop. And it can only really go into one of these. So these things are all pinned correctly for that particular port. All right. And we need power for the printer. So good old 3-prong power cable. Connect that one end into the cable, the other end into our power strip. All right. So we got our monitor all connected. Now we need to work on our printer. What type of cable do we need for our printer? I think it says it's a USB on one end. What is the other end of our printer? Standard printer. Stuff that I'm manipulating my. All right. Okay. So which of these cables? We need the Cat 6A power adapter, this USB, it's called a universal standard. Most printers will take this type of cable. And it has the USB type B on one end and USB type A on the other. And these type of printers, as far as their connections, have been around a long time. So one end goes into the back of the printer, and the other end will go into one of our USB ports on the back of our PC. All right. So we got our printer. Our printer needs power. So we do have this HPAC. And remember, printers have their own specific cables for power. So you do have to be very careful if you have a bunch of cables that you're connecting the right cable for your printer. That's the environment's a little wacky here. All right, and this even gives it's even color coded. So this is an HP printer, so we know it has this little purplish end that will connect it to the back of your printer, and we want to plug that into the power strip. All right, so we got our printer ready to go, our monitor, all in the power strip. Okay, so now we want to make sure our computer is connected to a wired network port. And yes, that's where the Cat6 Alpha, it's your networking cable that plugs into your network card on your motherboard. And there's usually a Cat6 port. So we plug the one end into that port on the back of your desktop, and then the second and into your Cat6 port in the wall. And you'll notice that these ports, well, it'll be passe pretty quick, but just point of reference, you have an RJ45 and RJ11. RJ11 is the old phone line cords, and it's a little thinner. So, and the network cable will not fit into that port. So that way, you know that you now have network connectivity. All right. So that means that we should have all the components connected. And let's see if our computer is ready to be booted up. So let's turn on our monitor. Oops. And our PC. And make sure we get a good boot. And we have network connectivity. And if we click on our network and internet settings, where we know that we're successfully connected and we have power, and we're good to go for computing. All right, any questions about that lab?
No.
Nope, are we good? Oh, we better score ourselves. Yay. And remember on these labs, basically you want to shoot for 100%. Most of them you have to score 100% to pass. So if there's something wrong, if you get one of the red checks, oops, you want to go back and do it again. And the whole purpose is that we want you to do these labs as many as you need to feel comfortable with what you're learning. All right. All right. Great. That wasn't too bad. Now we have a video. We're going to go into chapter 2 on our chapters for LabSim. And we're going to watch a video. I'm going to kind of skip ahead a little bit. Oops. We're going to watch a video on PC maintenance and best practices. Yeah, and this is actually a pretty good video because it will help you to maintain some of the factors on your own PC. So let's.
In this lesson, we'll discuss PC maintenance. Maintaining your computer equipment will help extend the life of the components. The first thing you need to look at is creating the proper environment for your computer hardware. This will help your hardware last longer. Some considerations include keeping the temperature between 70 and 74 degrees and keeping the humidity levels between 40 and 70%. Make sure the computer rooms have separate and redundant cooling systems and use a positive pressure system in your computer rooms and wireways to ensure a supply of good, clean, filtered air. Frequently clean systems which operate in a dirty, dusty, or smoky environment. Protect your systems and network cabling from electromagnetic interference, or EMI. EMI is generated by motors, machinery, and even fluorescent lights. You can use shielded cables or run your network cabling in conduit to prevent EMI. Fiber optic cable is not susceptible to EMI. Radio frequency interference, or RFI, can disrupt wireless network traffic. RFI can be generated by cordless phones and other home automation hardware. Wireless networks that operate within the 2.4 gigahertz range are particularly susceptible to RFI. This can be overcome by moving to a wireless solution that operates in the 5 gigahertz range. Data stored on magnetic media like disks and tape is at risk from any source of a magnetic field, such as speakers, motors, and fans, and even space heaters. Solid state and flash storage devices are not susceptible to this kind of data loss. Proper computer maintenance includes periodic cleaning. Dust and dirt will insulate PC components, trapping heat and shortening the life of your computer. Some common cleaning supplies include a lint-free cloth, compressed air, an anti-static and microfiltering vacuum cleaner, and denatured alcohol or isopropyl alcohol. Always power down a system before cleaning and use caution with liquid-based cleaners. Never apply a liquid directly to a PC component. You'll use the denatured alcohol to clean electrical contacts. Use a dry, lid-free cloth or a special LCD cleaning solution to clean LCD screens. Keyboard should be cleaned with a small PC vacuum cleaner or compressed air. Inkjet print heads should be cleaned with a manufacturer's supplied utility. Excess toner should be removed from a laser printer with an anti-static and microfiltering vacuum. And lastly, use only a special cleaning disc and its related software to clean CD or DVD drives. CD and DVD discs can be cleaned with a soft, dry cloth. Here are a few more considerations to help you ensure a long life for your PC components. When you receive a component that has been shipped to you, allow it to sit at room temperature for at least 6 hours. This will dissipate any condensation that may have been caused by a rapid change in temperature or humidity. Use covers and cases to protect equipment when it's not in use. Use cable ties and anchors to keep cabling organized, and always perform regular backups of important data. That's it for this lesson. We discussed several different things you can do to extend the life of your computer equipment, like maintaining proper temperature and humidity, protecting your systems from interference and magnetic fields, and cleaning your PC components.
All right, you'd be surprised how effective that general maintenance will help to keep your computers running efficiently. All right, great. So we have one last lab, and we're going to install a UPS. How many of you know what a UPS is? Uninterruptible power supply, power source, which means basically if you lose power to your outlets, it's essentially a battery that will supply power to your PC once you lose power to your devices. So, all right, let's get started. So you are the IT admin for a small corporate. The area around your office is under construction. Yeah, that always helps. The power company informed you that there may be a short interruptions to electrical service that could last up to 15 minutes. You need to add a UPS to the workstation and monitor in Office One so that you can save in the event of an outage. So the UPS protects against over and under voltage conditions. Basically, it provides a way to maintain a power source in case there is a power loss. So we're going to add a UPS to your computer, plug the UPS into the outlet and turn it on, plug the computer and monitor cables into the appropriate UPS outlets, plug the printer into the appropriate UPS outlets, connect the network cables to the UPS, through the UPS to the computer. The cable from the wall connects to the import, and connect the USB cable to the UPS and the computer. All right. Okay, into our simulation we go. Okay, so the first thing we want to do is add a UPS for our computer. So the UPS will look something like this. Some of them are large devices, but we're going to go ahead and add this into our environment. And you notice it has outlets and a power on-off switch. And the first thing we want to do is plug it into our outlet. And basically you do that because it's actually like a large battery. There's other things going on in it, but it will maintain an AC current for your devices. All right. So plug the UPS into the wall outlet and turn it on. So we're gonna turn it on. And the switch, our power switch is normal, just to, yeah, normally that indicates power. And now we know that it's actually on. Okay. Now we want to plug the computer and monitor power cables into appropriate outlets. And basically we have our cables here. And we are connected to the back of our desktop. So we're going to plug the outlet portion into one of the outlets on the UPS. And we want to do the same for the monitor. So now both the desktop and the monitor are plugged into the UPS. Now we want to plug the printer into the UPS. So where's our printer? So when we select our printer, we do have an outlet cable here, and we want to plug that into a port on the UPS. All right, and it's an HP LaserJet 1300, pretty nice printers. Now we want to connect the network cables through the UPS to the computer. That sounds suspicious. How do we do that? So we have our network cable, right? Remember our RJ45, we have one portion in the wall here and one portion to our computer. We are tasked to plug it through the UPS. Okay, now how do we do that? If you look on the side, we do have, or do we have?
Lane.
Go ahead. We have a network out and network in. And basically what that does, it protects the network connection because sometimes you have power over the network. And we will talk about that in our networking portion, but let's take a look at that.
Take the one from the PC and into the.
Yep, we're getting there. All right, so we know we have network out and network in. So which one goes into network in?
The one in the outlet coming from the wall.
So we take this one and we take it out of the wall.
In.
And we go to in. Are you sure?
No, out.
Yeah, but we want to, don't we want to leave this one in the wall or no?
Either way.
Because this is still our network, this is still our wired connection, right?
Yeah. You can take it either way. You still need a second cable.
So we need another set of cables, right?
Yeah.
So what we want to do, let's take the one from the PC. And where do we want to put that one? Which port on the UPS?
And the in.
So this is the one that's plugged into the wall, right? So we would put this in network in because this is bringing the network from its wired connection on the wall, right? So now we have network to the UPS. So we want to take the network from the UPS and provide it to our computer. All right. So we want to take another cable off our shelf. We want to plug one into your network out. And we want to replace that cable that we just So now, do we have network to the computer with that? What do you think? Are we in agreement? Are we sure? Yes, no?
Yes.
Okay, I was just looking for
Yes.
confirmation. All right, so we have network coming out of the wall into the UPS and out of the UPS into the PC. All right. Now, we want to connect the USB cable, connect the USB cable to the UPS and the computer. USB, excuse me. USB, UPS. Now, what do we need a USB cable for the UPS? Any answers? Go ahead.
To plug it into the computer,
For what reason?
so you can communicate.
There you go. It's a communication um, portal. So it's a standard universal USB-B that goes into the US. So we can actually control the USB from the PC with this communication. It's a communication cable. And this will go into one of our USB ports. So we just plug it into one that's open. And now we have everything. So what will happen on your PC, you'll monitor activities with the UPS. And basically, you can create logs, etc. When the power went out, the battery life, you can create status, and everything that you would need to understand about the power. Now, are we all set then? Are we all good to go? Yeah, we seem to have power. And we're able to boot up. Let's just check to make sure we have networking, and then we'll be done. And everything looks good. We have our networking, and generally you will have another status icon. We probably can't simulate it here. That'll say that you're connected to the USB. All right. Okay. Any questions about that lab? Let's see how we did. Oh, we didn't pass. We didn't do something. Oh. Plug the printer into the surge suppressor side of the UPS or the wall outlet. We forgot to unplug the printer from, and we'll go over that. And basically, because Adam is going to swoop in here, but we forgot to take the printer power from, or did we? I thought we plugged it into a regular outlet on the UPS, but there's some surge protection on the UPS as well. And we'll talk about why you need to differentiate between devices that need surge protection, if there's a spike, and devices just that need regular. And I'll briefly say that you notice that on the PC and the monitor, they're three-prong. You have the three-prong cables, and they're essentially grounded, so they're protected, where the printer has only two-prong, and it's not really technically protected from spikes in the power. So yeah, we would have to go through the lab again. Make sure when you go through the lab, you take a look at the UPS. It does have ports, plug-in ports that provide surge protection. So, but I need to give up control of the lecture and have Adam come in and warp your minds even more than he already has. So
Wow, thanks, buddy.
you're welcome.